A Grignard reagent is used to make carbon-carbon double bonds. Grignard reagents are made up of an alkyl group, a magnesium atom and a halogen. What's interesting about them is that the carbon carries a slight negative charge, so it's really easy for it to then react with another carbon that's got a slight positive charge. There's a lot of preparation to do for a Grignard reaction, and the most important thing is that there's no traces of moisture in the reaction at all. This will break down the Grignard reagent really quickly. So all of the glassware that we're using has been in the oven for 24 hours at 105 degrees, and all of the reagents that we're using are dried. This ether has got sodium in the bottom of it, which is going to absorb any moisture present in the reagent. We'll need to pack a couple of drying tubes to keep everything really dry during the analysis. Get a little bit of cotton wool just to plug up the tube. And then we'll use calcium chloride granules. These granules will absorb any water that might be sucked into the tube. Just use a funnel and pack the tube with about 2 centimetres or 3 centimetres of calcium chloride. And then we'll just put another little piece of cotton wool at the top so it doesn't fall out. It shouldn't take too long to get the glassware together for a Grignard reaction. Start with a clamp. Make sure you put it on this way, not this way. We're going to use a 3-neck flask for this reaction. Clamp from the middle neck because it's the strongest. Attach a dropping funnel. You can tell a dropping funnel because it's got the quick fit connection at the bottom. And put one of the drying tubes in the top. You're going to need a little bit of space underneath this flask so you can use an ice bath or some hot water or your hands to warm it up. About that's the right height. You might like to use another clamp on the condenser because it's really long and it needs a little bit of stability. Put the other drying tube in the top of the condenser. And we'll just use a cap to close off the other flask lid. So this is what the final apparatus should look like. Of course, we're going to set it up in the fume hood because we're using ether in this analysis. To start the experiment, add your magnesium turnings into the bottom of the flask. Mix together some bromobenzene with 40 ml of sodium dried ether. Make sure that the separating funnel is closed and pour the reagents in through the top. Add about 10 ml of the reagents to the bottom of the flask. The reaction might start straight away, but it probably won't. You might find you need to put a little bit of heat by putting your hands around the bottom of the flask and warming up the ether. Or get a hot water bath and warm it up like that. If the reaction doesn't start after a few minutes, get a glass rod and just very carefully crush a few of the magnesium turnings with the glass rod. Sometimes they get a layer of oxidation products on the surface of them and they're not really very reactive. Be really careful when you're doing this that you don't poke a hole in the bottom of the flask, and make sure you always have your hand underneath it to protect it. Ether's got a really low boiling point, about 37 degrees, So it doesn't take very hot water to get it to boil. So at this point you might like to just put it in some water that's about 40 degrees Celsius, just to try and get the reaction started. When you see little bubbles like this coming up, the reaction's starting. I'm just going to add a little bit more of the bromobenzene, see if we can get the reaction going. You can see it's boiling quite vigorously now. We want it to keep boiling under reflux for about 15 minutes. You can see the ethers evaporating and then hitting the side of the flask and condensing back down again. That condensation shouldn't go past about halfway up the condenser, or you'll be losing some of the ether. I'm using an air condenser today, so I haven't got any water running through this condenser. If you find it gets too hot and vigorous, you might need to put some water through the condenser. As the reaction proceeds, the colour of the solution will change from clear to a dark murky brown colour. This is mostly due to the formation of oxidation products from the magnesium, like magnesium oxide, but also if there's impurities in the magnesium, they'll come out at this point. At the end of the reaction, you might find there's still quite a bit of magnesium left in the bottom of the flask. Don't worry too much about it, but don't pour it into a separating funnel. I'll put 8 ml of benzaldehyde in the separating funnel, together with a little bit of ether, and slowly add it into the reaction tube. As you add the benzaldehyde, the alkoxide ion's going to form, which is quite insoluble in ether, and it looks like a white powder. Once all the benzaldehyde's added, take off the dropping funnel. Once again, put some warm water underneath. After this has been boiling for about 30 minutes, we're ready to finish the reaction off. We don't need the drying tubes anymore because we're just about to add some water to the solution, so it doesn't matter if it gets wet anymore. And we'll just cool our solution in an ice bath for a few minutes. Slowly add some cold sulfuric acid over the next 20 minutes or so. This reaction can be quite vigorous, so you just want to add the acid very slowly with swirling, keeping it on ice all the time. If it's a hot day, I'd also put the acid on ice. You'll see that the alkoxide starts to separate from the solution, looks a little bit like lumpy milk. As we add the acid, the alkoxide ion protonates, turns into dimethyl alcohol, the product we're trying to make, and dissolves back into the ether. If you've got a lot of magnesium left in the bottom of your flask, it will react with the acid to form hydrogen gas. Overall, the process of adding the acids should take you about 20 minutes. There's a layer of acid at the bottom that's reacting with any leftover magnesium in the solution. That's producing hydrogen gas bubbles, which are moving up to the top in little clusters of bubbles. As they move up, any light bits of magnesium get picked up in the cluster. You can see as the bubbles burst, the magnesium falls back down. This will keep going until all the magnesium has been used up. At the end of the analysis, you'll have two layers like this. The bottom layer is just the sulfuric acid, and the top layer is the ether, and it's got your product in it. What you need to do with this now is put in a separating funnel, wash it a few times and dry it off with some magnesium sulfate, and then evaporate off all of the solvent to be left with a solid white compound, which is your product.